Let's solve the sequence problem that involves both arithmetic and geometric sequences. Let's start with part A, which deals with an arithmetic sequence. We're given that the sum of the first 30 terms is negative 1,065, and the sum of the next 20 terms is negative 2,210. We need to find the first term and the common difference. Let's use the formula for the sum of an arithmetic sequence. The sum of n terms equals n over 2 times 2a plus n minus 1 times d, where is the first term and d is the common difference. For the first 30 terms, we can substitute n equals 30 and s sub n equals negative 1,065. Simplifying this gives us our first equation, negative 71 equals 2a plus 29d. For the next 20 terms, we need to consider terms 31 through 50. The first term of this section will be a plus 30d. After simplifying, we get our second equation, negative 221 equals 2a plus 79d. Now we can solve these equations simultaneously. Subtracting equation 1 from equation 2 eliminates a. This gives us negative 150 equals 50d, so d equals negative 3. Substituting this back into our first equation, we can solve for a. 2a plus 29 times negative 3 equals negative 71. Solving this gives us a equals 8. Now let's solve part B, which involves a geometric sequence. We're given that the first term is 4, and the sum of the first 3 terms is 7. We need to find the two possible values of the common ratio and the sum to infinity for the convergent progression. For a geometric sequence, the sum of the first 3 terms is a plus ar squared. Substituting our values and simplifying, we get 4 times 1 plus r squared equals 7. Rearranging into standard form, we get our squared plus r minus 3/4 equals 0. Using the quadratic formula, we get our equals 1/2 or negative 3/2. For the sum to infinity, we need the absolute value of r to be less than 1. Therefore, we can only use our equals 1/2. Using the formula over 1 minus r, we get 4 over 1 minus 1/2, which equals 8. So our final answers are, for part A, equals 8 and d equals negative 3. For part B, r equals either 1/2 or negative 3/2, and the sum to infinity when r equals 1/2 is 8.